Hello, everyone, and welcome to our latest online event here at the University of California, Merced. My name is Ricky Hill, and I am your e-recruiter. And once again, I'm here with you, getting ready to kick off this great event tonight. We are going to be talking about electrical engineering. What a fantastic topic. So I'm so happy that you're joining us here tonight. Thank you so much for taking some time out of your evening. Let me go ahead and give you a couple of quick Zoom reminders before we get started. If you need to adjust your audio settings, you can do that in the lower left corner of your screen. If at any time you would like to zoom into your screen just a little bit more, you can click on View Options in the upper portion of your window. We always have that Q&A option available for you, so make sure that you do click on the Q&A button at the lower portion of your screen, and we will be able to get to those questions live at the end of our presentation this evening. Once again, we're so thrilled that you could join us. In case you'd like to watch this later on as an on-demand instant replay, we are recording this for you this evening. That will be available in the next day or two, and we will make sure to drop into the chat box that link for you so that you can get over there to that replay in the next couple of days. Once again, my name is Ricky Hill, your e-recruiter. We are talking about electrical engineering tonight, and we have a fantastic special guest tonight, Dr. Sarah Kurtz. Welcome.
So thank you for the introduction, Ricky. I'm very excited to talk with you about electrical engineering today. It's a new thing here at UC Merced. We are just in our second year. The one question you might ask is, why electrical engineering in the first place? You've probably noticed that the world is changing place. You were born into a world that's changing rapidly. We have smart locks, smart phones, smart thermostats. You turn around and there are electric gizmos everywhere that are helping us live our lives in a way that is more fun and more effective and more convenient. Have you ever thought about, I would guess that each of you has at some point been at a place where the power went off. And I know the other day the power went off at my house and it was like, oh, like everything stops. And then you think, what can I do? Oh, I'll go do this. And then I think, no, I can't do that. I have to have some electricity to do that. Oh, I could do that. No, that needs electricity too. I feel really disoriented when the power goes off because so many of the things I do in my life require some power. I can go outside and pull weeds. That's fine. I don't need electricity for that. But there's so many things I need electricity for. Almost everything we do today requires electricity. So what we've done is to create a new electrical engineering program. It's accepted its first students last fall, and it will graduate its first class in the spring of 2027. We've currently got 4 degrees approved. One is just a regular bachelor's in electrical engineering. But for those who might be interested in electric vehicles, we've outlined a curriculum with courses that especially highlight electric vehicles. If you've ever ridden in an electric vehicle, you know that electric vehicles are a great thing. They have great acceleration. They're cleaner. They actually, if you charge them with solar or wind electricity, they may use a third the energy of what it takes to power a regular conventional electric vehicle, a conventional vehicle. If you think about the car you normally drive in, it has this big radiator in the front. The radiator gets hot and you have to dump all that heat. It's because it's waste heat. It's energy that's lost. Electric vehicles don't have that big radiator in the front. So electric vehicles are something that's really exciting that's coming on that will change the way we live. The next area of emphasis is ground and aerial robotics. You've maybe all seen like drones. There's also aerial vehicles that we can take up with spaceships. Don't know. I hope all of you were able to see how recently they launched a rocket and then caught the rocket coming back down. New things are happening in the world, and being able to learn more about the robotics is a useful thing. And then sustainable energy, my personal area of expertise. I've worked with solar energy for maybe 40 years, and solar energy has gotten so cheap that you can buy a solar panel for about the same cost that you can buy a window of the same area. And so now the challenge is to figure out how we integrate that solar into the power system to be able to power everything we have. Then we have two new degrees that we've proposed. They're not officially approved yet, but they're most of the way through the approval system. And these are computer engineering emphasis, where you can learn like how a computer is assembled, how the different parts of it fit together, and machine learning. I think you're all aware of the artificial intelligence and all of the it's a new buzzword. I don't know if you know what machine learning is, but one way to think about it is if somebody gave you the job of taking a picture and deciding whether it was a picture of a cat or a picture of a dog, would you be able to do that? It turns out that machine learning is a really useful tool for doing that. And so with these new areas of emphasis, you would be able to learn both about how a computer works, or you can choose to learn more about how we use like artificial intelligence and machine learning to do complicated tasks. We've put together a curriculum that we find is very engaging to the students. So we've looked for hands-on activities that you can start in your very first semester. So for example, we start in the very first semester. Here's a picture of two of the students. They have a meter in their hand and the solar cell is on the ground collecting the sun's rays. And we use the solar cell as a way to learn about current and voltage. And current and voltage are the foundations of how we understand about electricity. And the little solar cell you can find makes a small amount of electricity, which we can then characterize. We do a couple of other activities also in the first semester. Then in the second semester, the students learn to use some simple programming and simple circuits to put together things that will move or lights flash. And so in this particular case, we have the student on the right has made a little tiny robot. And again, if you get into the ground and aerial robotics, you're learning more about how do you make this thing go? And what it's going to do is to follow the black path. And you can imagine that what you need is a sensor which can detect whether it's on the path or off the path. And then you need some software and hardware together that detects whether you should go to the right or the left, and then it can steer around it. And so you'll watch, and the video shows that the vehicle can actually steer itself and follow the path and get back to its home base. We found that the students really like being able to get engaged in this way. If they just start with calculus in the first year, it's like, okay, I can work all of this algebra and all of these calculations, but what am I going to actually do with this? And so it's fun to be able to actually make things move, to make lights flash, make sounds happen, or whatever. We do have now a whole set of faculty. One of the reasons why students often will tell me that they've chosen to come to UC Merced is that UC Merced has one of the highest rates of the highest fraction of students participating in undergraduate research. And so I'd like to introduce you briefly to each of our faculty members and the type of research they do. So Dr. Eric Cheng, who I believe is actually on the call and may be able to answer any questions you have about his research in a moment when I've finished. His work is on looking at, say, electrical mobility. So he has actually engineered both a golf cart and a bus, and we can maybe give you a link to a video where you can see how he can take ammonia, convert it to hydrogen, convert the hydrogen into electricity, use the electricity then to run to charge a battery that then runs the bus or the golf cart. He is also very good at a number of different types of systems, including wireless charging of things, automated wheelchair, and various things like that. I already mentioned to you that my area of focus has been more sustainable energy, and especially my area of expertise is solar energy. I'm also looking right now at two major projects. One is how we can grow plants under solar panels. And so you can imagine that if the farmers can both use their land to generate electricity and grow food, that makes dual use of that land. So that's an exciting thing if we can make that work at a large scale. The second one is that we're looking at tandem solar cells. So a new kind of solar cell, and we're testing it outdoors to see how well it can work. The third faculty member, Dr. Chunking Lee, does biomedical imaging. So he's an expert on using X-rays to take pictures of the insides of things. And so it can be fun. Not only can you use that to image things inside of your body, but like if you want to take your suitcase, he could probably image the X-ray things inside of your suitcase. Then Dr. Ayush Pandey, his expertise is more on the artificial intelligence, machine learning, and more calculations kinds of things. Dr. Mukesh Singhal is doing more cybersecurity. It's an interesting thing. You've noticed that now in today's world, people hack into things and take control of things they shouldn't. How do we protect ourselves from that? So he's focused on that. Dr. Chan Wang, the sixth on the list here, is also interested in cybersecurity, but she looks more at the physical aspects of how do you design a system. And her area of expertise is to design chips. And historically, we've had like the central chip in a computer is something that you program it to do lots of different things. But now we can actually program chips to do a single task like artificial intelligence, and it can be much more efficient at executing that task if it's specially designed to do that task. And so her area of expertise is to be able to do the design of those chips that can be used for specialized things. So we will be hiring more faculty as the program grows, but these are the 6 we have currently. A new program provides opportunities to create new traditions, and it's been really fun with the very first groups of students who've come in, that they'll make suggestions to me. This year we've done a t-shirt competition that we've just selected a winning t-shirt, and we'll be making t-shirts. In fact, if you come to one of our Bobcat Day or one of our other recruiting events, I might have one of those t-shirts to share with you. And what are other traditions we'd like to develop? We'd really like at this point to hear what you would propose. So I'm going to stop now sharing and open it up for either your questions, or if you have, you can have questions, you could have suggestions. We do have Dr. Eric Cheng with us if you'd like to hear more about his research. And but I'd like to hear, what ideas do you have about things you'd like to do, or what questions do you have about electrical engineering?
Thank you so much, Dr. Kurtz, and welcome also to everyone if you're just now joining. I've gone ahead and opened up our chat feature, so you should have access to that if you'd like to go ahead and type there to us what your ideas are, or if you would like the opportunity to have access to your microphone and come on live with us and share your thoughts that way. We would love to allow you to do that, so go ahead and use the raise hand feature. That will give me a cue that you are interested in coming on live with us, and I will go ahead and give you access to your microphone. Once again, you do also have the chat box feature, so we can also give that to you as well. And then Dr. Chang, also, if you would like to do an introduction, this would be a great time to do that.
Hi, thank you so much. And my expertise mainly on energy and also in motor actuation system. So my research area, the so-called power electronics, is to use electronics to control the power. So the power can be something like control a motor, control a whole power system, control the home utility, or maybe control an electric vehicle or electric aircraft. I think in the near future, many of the equipment will go on more electric. For instance, I think today we got roughly about 3% of vehicles are electric. I guess in, say, 20 years' time, more than 70% of vehicles could be electric. So in this case, we really need many more electrical engineers to work on this area. So we need a design engineer, we need some maintenance engineer, we need something to support all the electrical system. And I think today we are not talking about robotic. A robot, we do need a lot of the motor control. The motor could be something like linear motor, rotational motor, could be 3D motor. So how do we design a motor for the robot? how do we give the energy to the robot? We don't like robot to charge the robot every 30 minutes. We want to charge the robot maybe every a few days. So we need to develop an electrical system for the robot. I guess in 20 years' time, everyone will have a robot together with you, similar to today we have a phone. So there's many things are going on for electrical engineering system. So that's what I like to say. So later I can share a link to you so that you can see some of my research work, including how to power up an electric vehicle using a new energy. So the new energy we are talking about today, not battery, not hydrogen, a new energy called ammonia. Ammonia is one of the fuel is zero carbon emission. So that's some of the research work I'm now working on.
Wonderful. Thank you so much. I just want to remind everyone, if you'd like to come on live with us here, go ahead and use the raise hand feature. I do see someone who raised their hand earlier, David. If you are still interested, go ahead and just drop me a note in the chat box. I did send you a message and I can go ahead and give you access to your microphone. Or everyone, the chat is also available. So if you'd like to send us your thoughts that way or questions, feel free to do that as well. We also still have the Q&A button available, so we will also be keeping an eye over there. Dr. Kurtz, did you have something you wanted to share?
Yeah, so I see that there is one question in the, do you think there will be a depth in electronic devices and materials in the future? And Mariah, maybe you could clarify, I think you're talking about in the curriculum rather than in the research. And clarify if I didn't understand that right. So yes. Oh, and Mariah, would you like to actually speak? And then I can hear your question directly. Or maybe you're on mute. So we will, I didn't give you the full list of classes. That's a long list of classes. You can go online and see those. Maybe I can put that in the chat in a moment. We do go into a lot of depth on electric circuits. We have one class in the sophomore year that's on circuit theory, in which you assemble very simple circuits. And then in your junior year, you start with the electronic circuit design 1, and then there's electronic circuit design 2. And so by the time you've had the third class in the electronic circuits, you have an understanding of more advanced circuits. There's also a class on semiconductor devices, and that involves understanding how the semiconductor materials work to actually create and do different functions. And so that's a class you would take in your junior year.
Very good. And again, just a reminder for everyone who's on with us, go ahead and use the raise hand feature if you would like to open up your microphone. And Mariah, if you do have a follow-up, I just saw your follow-up saying thank you. Well, thank you for sending in your question. If you would like to come on though with us, I have given you permission on your microphone. So all you'd have to do is just unmute and you could come on and join us in our conversation this evening. It does look like we have another question there that's coming in. Do you see that, Dr. Kurtz?
Yes. I see one that says, will there be a section in this meeting for aerospace engineering? And we didn't design this one tonight. The aerospace engineering is a brand new, degree program. But I think we will have some overlap with the aerospace. I would encourage you to explore that separately. Then there's another question here. Is there research being done on renewable energy using biomass technologies at UC Merced? So one of my students has published a paper about how we could use biomass, that maybe we collect the biomass during the summer, we generate electricity with solar during the summer, and then during the winter, on days when the sun is low in the sky, we can use the biomass to generate the electricity. So biomass and solar working together form a very good partnership of how we can provide power for the entire year. There are others who are looking at various forms. I just actually talked with someone who's doing a video about biogas and looking at the gas that comes from dairies. You can take the methane coming out of the digesters from a dairy farm where the manure and other waste is digested and creates the biogas. And then you can use that biogas in much like we use natural gas. What would a first semester for incoming transfer students, probably akin to a junior year, look like at this time? So we're not accepting juniors this year, but for fall of 2025, the transfer student needs to have physics, a year of college level physics, and needs to have circuit theory, needs to have about 4 semesters of calculus. And assuming that you've had that set of courses, then you're ready to go in. We have 3 classes we expect that you would go straight into in your junior year. So one is the circuit design one that I just described, which is looking at how you put together transistors and various things into a circuit to make them do various things. Another is looking at signals and processing. If you have a radio and you get a signal that you take from the air, and now you want to get the audio signal out of the signal that you detected from the air and turn it into into what you can hear in a microphone. So that would be something that signals and processing would do. Also today, signals and processing sometimes begins to look at other kinds of signals, not just the signals from a radio. And then we would have the third class that I just described to you, the semiconductor devices, where you actually try to understand how a transistor works. And there are today there are many new kinds of semiconductor devices. So I think that that's a reasonably good introduction. If the transfer student doesn't have all the calculus, physics, and circuit theory class that we need, then the student will have to catch up with those before being able to take the upper division classes. So we want to make sure that you've already had those. Then, so hopefully, Nathan, that answered your questions. And again, if I didn't answer the question and you want to come on and have a dialogue, Ricky can set you up to come on. I see a question from Mia that says, hi, I was wondering what projects or research would an electrical engineering major with machine learning do during college? So there could be a variety of different projects there. God, there are so many different things with machine learning that can be done. But you first have to learn the basics of machine learning. And then let me give you an example that's good for me from solar. One of the things we need to do to figure out if the solar energy can match the load profiles. So we always have to balance the amount of electricity we generate with the amount of electricity we use. But a question is, how much electricity are we going to use? And machine learning is an example of how you can take the historical data and see. With machine learning, you can figure out that, oh, if it's going to be hot, we're going to have higher electricity demand. People are turning on the air conditioners. Or if it's rainy, then maybe we don't turn on as many air conditioners. And so machine learning, an example of how you could apply that would be to see if you could predict that the load that we'll see tomorrow, because of the of what we've seen in the past. And machine learning is a good tool for doing that. I think I'm seeing that there are a lot of questions building up, so I'm going to keep trying to churn through. Ricky, am I doing okay? Go to the next Q&A.
You're wonderful.
The next one I see is, would you recommend focusing more towards electrical or mechanical engineering for mechatronic? So first of all, that's a very informed question. A lot of people don't know that mechatronics involves both electrical and mechanical. So if you come to UC Merced, you would have 2 different options. You could either get a mechanical engineering degree and get a minor in electrical engineering, or you could use, probably I would recommend, if for mechatronics, of the areas of emphasis that I just described for you, the one that had to do with robotics is really a very good application, where we have electricity and mechanical things coming together. And a robot is using electricity in a controlled way to move something in a way that's very controlled. So you need also the software, which we're going to also provide to you, because we alongside of any circuit nowadays, because everything's a smart circuit, we're going to need to have some software that takes the sensor takes the electricity and then makes things move. So I think you can do it either way. We'd welcome you. The electrical engineering program is a little bit smaller, so the class sizes may be a little bit smaller, but both electrical and mechanical engineering are very valuable degrees, and you can do it from either side. Then I think I should switch over maybe to the chat. I see, oh, maybe you've been answering some of the questions in the chat. Is that right?
Yes, we have Caitlin behind the scenes who's also been assisting with some of the questions as we've gone along here.
Okay. So are there any other outstanding questions at this point, or do we have any students who would like to make a suggestion about projects you might like to do? Like, should we set up for you to make, I just visited one of the local universities that was saying that you would be able to make like a windmill, and then we'd have a fan and see how fast the windmill moved. That's also a combination of mechanical and electrical. So there's a question here about what are the plans for ABET accreditation. Our plan is we can't apply for ABET accreditation until we've actually graduated a student. But as soon as the student has graduated, as soon as we have a group of students graduating, we will be putting together all the materials to apply for the ABET accreditation. The process does take some time. I've been spending a lot of time talking with people about that process and whether that puts students at a disadvantage. If there is, so the students entering this coming fall, if you're applying for this coming fall, by the time you graduate, your degree should be able to be linked to accreditation, I believe. It may be for the very first year, it will be difficult, but actually ABET accreditation is mainly used if you're going to get a job in a government office where you review permits. If you make designs and you review the design and want to put a stamp of approval on that, for that you need to be licensed, and the ABET accreditation is useful toward that. Having, I should say, let me clarify. The ABET accreditation, if you've graduated from an ABET accredited university, you're able to take the exam, which gets you licensed sooner than if not. But it doesn't mean that you can't eventually, I mean, you still have to pass the exam. So the length of time it takes you to get your licensing, it doesn't matter so much, but when you can begin to start trying to take that test is a little bit sooner if it's from an ABET accredited institution. And we plan to be accredited as soon as we are able to. Then Nathan has another question. What have been the average class sizes for the program? So far we have we have a class of about 60. So we're looking in general about 60 students. Some of those, if it's a course that not every student takes, then it will be smaller. If it's a student that maybe some students outside of electrical engineering might be taking, then we might have a few more. But so far we've been about 60 for the big classes, and of course then the lab sections will be smaller, maybe 24 to 30 students.
And it looks like we have a few coming in now through the chat area. One of them here, what kind of support or mentorship is available?
For students who want to get involved in research or industry-related projects early in their studies. So, for example, I have, as I mentioned before, an open door policy. We have meetings every week. I have a project, for example, that is part of a national consortium where we are developing new kinds of solar panels. And our job here in Merced, where we have lots of sunshine, is to put the panels out and measure them. That consortium is with about 4 universities, about 4 startup companies or small companies, and 2 national labs. And we have meetings every week where students can come in and participate in that research. We have lots of little tasks about like analyzing the data. It can be just as simple as washing the tests, that if they get dirty outside, then the results are not very reliable. So we have to wash the solar panels that are outside. But we take the data, we may write some code to help us to evaluate the data more routinely. we also have the let's see. So I think then that was I think I finished answering that question. There are other, so each of the professors, so actually, why don't we give Eric a chance to answer that question? Eric, if a student would like to do research in your lab and maybe can get connected with a company, what opportunities would be available to them?
Yeah, because most of my research are application research. We like to create a product. For example, like if we work on my project like electric vehicle, then you may going to design a car or design the vehicle components. So this thing can become a future product. I do have a lot of collaboration with other company. So in this case, you may have a chance to design your work and then in the future work with a company. So like other system, we also working on the wireless power transfer. I guess in the future, a lot of the power distribution or transfer could be using wireless. So in this case, we're going to show you how to design the coil, how to make the wireless power transfer at high power or medium power, how to apply them in a real situation. So this kind of work will quite interesting. Can we really become a product or maybe can be your future startup as well?
Yeah, so just to clarify, some of you may have a cell phone that you can just lay it down on the charger and you don't actually have to plug it in. So this kind of wireless charging is especially interesting for, say, a train that maybe pulls up in the station, and while the passengers are getting in and out, in between the track, you can have the coils that could be charging that a battery in the train, so then it can go on to the next station. How about I move on to answering the next question I see in the Q&A? I always wondered, if you fail the exam for your job or something, are we able to retake it, or how does that work? So first of all, I want to make sure that it's clear that the job is separate from the license. And maybe one way to describe this is, if you have somebody, I think it's different for electrical engineers. If you make a cell phone, we actually test the cell phone. We don't require that every engineer who helps to design the cell phone knows what they're doing. In fact, we know that every engineer is probably going to make some mistakes. So we assume with something that's as complicated as a cell phone, we test the cell phone, not the engineer. But if you're building a bridge, or for that matter, if you're building an electrical, the electricity that comes into your house and you don't want to burn your house down, we want to make sure that the engineer who designs the bridge or who designs the electrical system coming into your house, we want to make sure they know how to do it in a way so that it will work. We're not going to test the bridge to see like how much weight are we going to put on it before it collapses. We want to make sure that the engineer who designs that knows how to do the calculations and to be safe. So what we do to do that question is, how do you know if that engineer knows what they're doing? Well, we create a way that we can license that engineer. And that, so the engineer then will, after they graduate from the university, they will work with another licensed engineer, maybe somebody who's been designing bridges for 10, 20, 30, 40 years, and they learn from them, making sure they know exactly what they're doing. And then when that person has enough experience, then they sit for the exam. And when they sit for the exam, they're not applying for a job. They're getting, it's like a certificate that says, I'm qualified to design a bridge. Now the job, when you go for a job, you'll go for an interview and they'll ask you questions. Do you know what a transistor is? Do you know what the difference is between current and voltage? Do you know? And they'll expect you to be able to demonstrate that you know how to do things. And you get the job because you answer the questions well during the interview, not because you take a big written exam. It's very uncommon actually to take a written exam. It's not impossible, but uncommon that you take a written exam when you're doing a job interview. So the job interview is, you can get a job without having the engineering license. But later on, if you want to be able to be the one who puts the stamp of approval to say that bridge will work, or this power system, if we put it into this house, is not going to burn the house down. If you want to get that kind of a job, then you need to sit and get your license. And Eric, would you want to add anything to that? I think you have actually been licensed to create the designs and do the approvals in a previous job, right?
That's right, yeah. I am qualified engineer from United Kingdom. During that time, after I graduate, and then we go through a so-called kind of the professional training for 4 years. And then my qualification in United Kingdom will enable me to become the qualification requirement to become a chartered engineer or so-called qualified engineer. And then after I got this qualification and then do 4 year training and then go for another so-called chartered engineer exam. Then after this, I become a qualified engineer in United Kingdom. The system will be similar in here. So after you graduate and then because our program will be accredited by the ABAC, and then after that you go for a PE exam and then also go for some training, then you'll become a PE, professional engineer. So I think all the systems are really similar.
So the question about if you're licensed or not licensed, does it make a difference in the pay? So one way to think about it is more about whether you're you get a job that's with a company that manufactures products. Usually they don't care much about whether you're licensed or not. The place where they care more is where you're building things. So if I mentioned building a bridge because it's something you can easily think about. But if you were building an electrical system that needs, well, there's an office in the city and the county government where if anybody's building a new house, they'll need to get permits that have both to do with the structure. You want to make sure that the walls of the house and the roof are strong enough that they're not going to fall down. And they also have a permit that's associated with any electrical work. And they need to have somebody who's licensed. So in that case, you will get paid more if you're licensed, if you're working in that office. Now, if you're working with a company that's either designing or manufacturing cell phones, then they don't care whether you're licensed and it won't make any difference in your pay at all. So you can get lots of different kinds of jobs. And in some cases, it does make a difference. In some cases, it doesn't. Then I think there was a question about tours. If you come on Bobcat Day, we will definitely give you a tour as part of the bigger Bobcat Day. I would love to say that anybody coming to campus anytime, we would give them tours. I might be able to accommodate that. I might not be able to. If on the day you come, I have the availability, I'd be happy to do that. But I can't promise to do everybody. But on Bobcat Day, which is a Saturday in April, we'll be pleased to host you and make sure. Actually, does anybody admissions know which weekend is Bobcat Day this year?
Yes, we do actually have that. Let me grab it for you here so I don't give you the wrong day. It is going to be Saturday, April the 19th.
Okay, Saturday, April the 19th. And so that day we will be planning to be there pretty much talking to people, and there are lots of people giving tours all over campus, and there'll be lots of things set up, including some of the clubs that are doing, like we have some very interesting robotics clubs or whatever. If you would like to get involved, you can talk with the students there and see the projects they've been working on. Now I see there's another one from Brandon. I do plan, not sure if it's something I want to, what. So if you're not sure, my recommendation, what you do, if you want to come and you're not quite sure what kind of engineering, we have a class I'm teaching right now that's called EE001. It's a 1-unit class. We just get together once a week for an hour or two. And we introduce to you what electrical engineering is. That's where I showed you the picture with the meters. We make sure everybody knows how to use a meter, how to measure current, how to measure voltage, what's the difference between current and voltage. We go through things like that, write a resume, go to a career fair, think about what it is you want to do with your career later on. Now, mechanical engineering also does a similar one. Most of the other engineering departments are doing an introductory seminar like that, where you connect with the other students in that area and learn a little bit about that, that engineering. And if you want to sign up for the mechanical engineering seminar and with ours, you can do them both in parallel and then make a decision at the end of the first semester about which direction you want to go. The curriculum for all of them is very similar, that you're taking mainly calculus and maybe the first year of physics. And so the very first semester, you don't really need to make a decision, and you can make the decision later. There's also the possibility of doing a minor, which you can find to be very interesting. So I hope that that maybe answered the question.
We had another question come in asking us to kind of compare, if we can, the electrical engineering major that we offer compared to other campuses.
So things that are a little bit different. One is that the two classes that I highlighted for you in the freshman year, there are a lot of electrical engineering programs that you come in and you don't really do much hands-on work until you get into the second year, maybe even late in the second year. We've made sure that, and I didn't talk about in the third semester, we have the programming class we offer involves not just programming, but programming a circuit that will make a light go on or make something move. So we've engineered ours to be more hands-on from the very first semester. So that's one difference. The other difference is the specific areas of research that our faculty have. Erica and I are both more focused on energy, but we also have the other, Eric is also focused on the mobility and robotics and things. We also have faculty who are focused more on artificial intelligence or the cybersecurity, as I mentioned, and designing chips also. So if you have an interest in the area of one of our faculty members, that will be something that will differentiate us from others. If you don't have the background, many of our students come in without being ready to place directly in calculus. And we do have a pre-calc course that you can take in your first semester and then move into calculus in your next semester.
Very good. And then just another quick reminder to everyone, just use that raise hand feature if you'd like to be able to unmute this evening, or you can use the Q&A button to send in your official question. The chat box is also open if you had some general thoughts that you'd like to share and contribute this evening.
And I'm interested in hearing what I haven't talked about that I missed. What would you like for us to be doing? So maybe that's something I should ask. If you're asking, how is ours different from other electrical engineering programs? How would you like to see ours be different?
That question is open to everyone. Our chat box is available for you guys to go ahead and drop in your thoughts.
So a question about, so we wouldn't be behind anyone who already took pre-calc. Certainly, if you've already had pre-calc, then that allows you to get started faster. If you're willing to take a class during the summer, one of the things you can do is to take that pre-calc during the summer before you enter the school. And if you have completed that, then you can go straight into calculus in the fall. You can still graduate in 4 years, even if you need to take the pre-calc. But obviously, you have more opportunity to get into advanced classes if you're already ready to go into calculus when you arrive. And do I see any ideas from people about what you'd like to see that I didn't describe yet?
Haven't seen anything come through quite yet, so we'll go ahead and keep that chat box open for everyone. So that way they still have another minute or so that they can go ahead and share that question with us if they have one, or those comments. And while we are waiting, I just want to let everyone know that to keep checking that chat area, because we are dropping some links for you over there. And one of those links is going to give you an opportunity to take a look at other upcoming events that we already have for you, as well as some that have already happened. So if you want to go ahead and take a look, you can either watch the on-demand instant replays or get yourself signed up for another upcoming event. So you want to make sure that you do bookmark that page. Also behind the scenes, we have some other fast fingers who dropped into that chat box the link for Bobcat Day that Dr. Kurtz did mention. That is one of our favorite days of the year. It is like Disneyland on campus. We have so many wonderful opportunities for you all that day for not only prospective students to kind of come and check out our campus, take some campus tours, also just get most of your questions, if not all of them, answered right there in one day. For several hours, we will be all set up. We have tabling events. There's performances that happen on campus. We have lots of different dance teams and groups. We have martial arts clubs. So you just really get a full 360 kind of experience of what being a Bobcat might look like for you. So we definitely want you to bookmark that page. We are still a little ways from April, so of course we are still building out our agenda, but I can tell you it is one of the best days of the year. So we hope that you will take advantage of visiting us on that day and at least marking your calendar and saving that weekend. So again, it's April 19th and that website is over in the chat area. Looks like we might have
Yes,
another
definitely.
Yeah, about internship partnerships.
Well, let me first answer the one about pre-calc.
Sure.
Definitely, community colleges offer pre-calculus courses. They offer pre-calc and calculus courses, and we definitely encourage you to take advantage of your local community college. It's a very easy way. And if any time during your time at UC Merced, there's like a semester that things didn't go well and you need to drop or repeat a course, you can often pick those courses up, at least from the first 2 years in the community college. The majority of the classes that we have you take in the first 2 years are taught at community colleges, making it easy for you to do those. And that's actually one of the reasons why we can accept then transfer students going straight into the junior level material, because they've done all of the first 2 years of classes at their community college. But then to go on to the question about the internships, yes, we definitely encourage our students to apply for internships, and we use Handshake as a platform that facilitates the students from to apply and link up to the companies. So the companies come in, open a Handshake account, post their internships, and then the students can easily go through and apply to whatever opportunities they find that look to be appropriate to them. Not all of it's more common for the students to get internships after like their junior year, but we did have some first-year students this year who got internships after their freshman year.
That's excellent. And right now, behind the scenes in the chat box, one of our fast finger sets behind the scenes did go ahead and drop the link to the admissions application for the UC system. So we want to make sure that again, that you go ahead and take a moment, click on that link, get that page bookmarked. That would be the link to the admission application, as I mentioned. Now, there is a deadline coming up. It's a little ways out into the future, but let me tell you, the time will fly by. So December 2nd is the official deadline for the UC application of admission for the fall of 2025. 11:59 p.m. on December 2nd. That is the deadline, and that is Pacific time. Hopefully, however, you won't be waiting until that very last day to do that, because of course we all know, especially in this session, what if you lose power? What if you lose your Wi-Fi connection? Then all of a sudden you're, a mad dash for the finish line. So make sure that you do start early. It's also a great idea to open that application and get familiar with some of those questions that we are going to ask you, like the personal insight questions. We also refer to those as the PIQs. And there are 8 total. You do need to answer 4 of those, no more, no less. And so it is a great opportunity for you to go ahead and start looking at that, get some of your responses drafted so you can start thinking all of those through and get your best foot put forward on that UC admission application. Again, that link is over there for you in the chat area, so you can click that and bookmark that for later on.
And I see Nathan has one more question there about the professors who focus on computer hardware or electrical hardware. Chen Wang is one who focuses on physical security hardware. And so this is a little complicated, but let's say, think about an electric vehicle, and the electric vehicle is collecting information from multiple sensors out there. What if somebody like attached an extra sensor and tried to start feeding you bad data? how would you detect that that was an invasive sensor, one that wasn't supposed to be there and maybe trying to create problems? Why do people hack into systems? I don't to do bad things. But anyway, if you're looking at security, you want to be able to detect whether the physical system is a good one. And so she is looking at the hardware. And one of the things she does is to actually design the chip. So I don't know if you know what the chip is, but when we make transistors, we can make an isolated transistor, or we can take one piece of silicon and put many, many circuits, many transistors on that to make a complicated circuit. So it's a little bit like you can take the alphabet and we can construct something by starting with the different letters, or we can start with the words, or we can start with some sentences, and we can do more complicated things if we start with a bigger building block. And so she's looking at how do you make the hardware that actually, instead of like taking a bunch of transistors and resistors and capacitors and wiring them up on a PCB board, can you actually do that directly onto a little piece of silicon? So a circuit that's this big now becomes a chip that's this big. And so she's looking at that kind of hardware development. But Eric Cheng, who's on the call here, noted that he likes to develop hardware. And so in answer to Nathan's question, Eric, how would you like to describe the electrical hardware that you might put together?
Yeah, one example would be we are now working on an autonomous vehicle. Autonomous vehicle, we have to put in a lot of hardware, including sensor, for example, like the LiDAR, GPS, ultrasonic sensor. All the sensors merge together and then go into a car computer to make a decision how to control the vehicle. So we will use a different kind of the chips in the vehicle and then do different kind of the control. That including how to select best route to go, how to make use of energy, how to control the motor, how to control the lighting, how to even to control the air conditioning system, how to control the charging. And in the future, the vehicle not only charge, maybe also discharge as well. These are not the thing we can able to control the vehicle using the vehicle computer. So our future project will work on this area, how to use vehicle control system to control the whole vehicles.
Good. So I didn't see anybody put in a suggestion of something else they'd like to see. It's not too late. We have a couple more minutes.
We do have just a couple of more minutes, and I think while we are giving those folks another moment here, what I'd like to do, I'm going to share a slide here so that way everyone can get some great info about the Students First Center. Hopefully you can see that now. That is a slide that has all the contact information for the one-stop shop on the campus of UC Merced, and we lovingly call them the Students First Center. Now, what do? They are exactly what it sounds like, a one-stop shop for almost every single question that you may have. You can go to them with questions about financial aid, admissions, anything with billing, payment plans that we offer, the deferred payment plan. If you have questions about residency, if you even have questions about housing, if they don't know the answer, they can direct you to the correct person and make sure that they do a warm handoff for you. So you're never left wondering, where do I go, and just kind of rushed out the door. We will make sure that you get to the right place, to the right person to get your question addressed. So make sure that you do take a quick screenshot. This information will be something that I promise you from tonight, even if you're a prospective student, maybe this is one of the first virtual events that you have attended, so you're just starting to dip your toe in the water here at UC Merced. I promise you this number and this contact information here that you see will be something that you use throughout your entire career at UC Merced. So the one-stop shop, they do everything that I just mentioned and more. You also see on your screen now some social media handles that we would love for you to follow. These are from the admission office, and you will be able to get reminders about when events like this are coming up. Also, once we have the on-demand instant replays ready for you to watch, we will put those links there as well. We also try to share some insight for you of different campus events, what campus life looks like. So we have TikTok, we have Instagram, X, formerly known as Twitter, Facebook. So we have you set everywhere, as well as a YouTube channel where we do also push out some information and some fun facts about campus. And again, wherever you're following us on any of these platforms, you will be getting all of that information at your fingertips. So make sure that you pick your favorite and you join us there right away. And before we take the slide down, that you do go ahead and grab that information with your smartphone. You can go ahead and take a quick screenshot and save that for later on. Now, it looks like we also put over in the chat box, there's a link there. Thank you so much, Caitlin. So you can just go ahead and click right on that, and that will hop you over to the Students First Center website. Now, we do have just another couple of minutes. So again, that raise hand feature is available to you. The Q&A box is also available, as well as the chat box if you'd like to just freeform text in what your thoughts are there. Even if they're not an official question, we are here to listen to those tonight as well. So as we do start to wrap up here, as we wait for, oh, it looks like Nathan, we have another question coming in.
So that's a very good question, Nathan. We haven't started the new emphasis area yet, but I think you would find the key difference of UC Merced versus elsewhere is that the faculty are really very much engaged with working with the students. And so if you wanted to work on a project, you would, for example, the IEEE chapter has looked at assembling things that might be pieces of a computer. They actually talked for a while about assembling a full computer, and the faculty are there to assist if you get stuck on something. So I think that you would have the opportunity to be a leader in terms of undertaking a project. If you said, okay, I want to be able to assemble a whole computer, let's do this, and we'll learn how to do it and learn from our mistakes as well as learn from our successes. You may also be able to do that at other UCs. I don't want to claim that you can't, but we'd be very pleased to work with you on a closer way.
Dr. Chang, would you like to offer any last words tonight?
Yes, I'd like to say a few last word about that. And I have a lot of the idea in different kind of the energy management. I think in the near future, the whole world will talking about new energy and new robotic control or new mobility. So all this area, of course, they already highly relate to how we use electricity to control the power, control the motor, and control the robotic control, we call it actuation system. So they're really interesting. We all need to use computer to control them. So that means if you're involved in our department, then you'll see all this research going on. We'll show you how to do all this hardware development or control system. The control system, we all need some computer control to control each of the hardware, each of the motor. The motor we're talking about can be really huge motor, as big as a vehicle, or as big as a big lorry, can be really tiny motor put inside our body. For example, like in the future, we're going to develop some artificial heart or some medical electronic. So we are using a really tiny little bit of the motor. So many work is going on. We tend to use electrical aspect to control many of the devices. So that means that would be a very interesting topic, interesting course.
Very good. Thank you both so much. Looks like we have a couple more questions coming in here. Or wait, maybe that last one just got grabbed behind the scenes here. And yes, I do see one there about the YouTube video. This has been recorded, so this will be available later on this week, and we will make sure to send that information out to you. And of course, it's always available on our social media network. So the information that you see there on the screen, you can follow us on any of those platforms, and you will be receiving those updates as well. Or you can go straight to YouTube at Life at UC Merced. Simply go ahead and click on that subscribe button, and then you will be notified as soon as I post that video. Dr. Kurtz?
Yes, so I tried to answer the questions, typing them, but certainly if anyone has questions that didn't get answered, feel free to email me. If I don't get back to you within 2 days, send me another email. That means I lost it in the too many emails, but I will try to answer.
Very good. Well, this has been such a wonderful event. So much good information has been shared. It is such an honor for me to be able to share the screen with both Dr. Kurtz and Dr. Chang. So thank you both as well for joining us this evening with so much good information for our audience. And of course, a big thank you to everyone behind the scenes who's been helping us out as well. And the biggest thank you of all to our great audience members. We wouldn't be here if it wasn't for you. So thank you so much for being interested in UC Merced. We definitely are interested in you becoming part of the Bobcat family. So make sure that you you do hop over to the application website. Those applications are for the fall 2025, so just about a year from now, you will become a Bobcat here if you go through that process. And make sure that you follow all of the dates and deadlines. There is a review process, and then we will start sending out those decisions months later. So make sure that you do take some time and mark your calendars. That application is open now, but it does close on December the 2nd at 11:59 p.m. Pacific time. Of course, don't wait until the last minute. Go ahead and get started on that earlier than later so you have a great opportunity to put your best foot forward, get those PIQ questions answered, and just be ready to go to submit that application even before that December 2nd deadline. Thank you once again so much for joining us. My name is Ricky Hill, your e-recruiter. It's such a pleasure. I hope to meet you very soon, either in person in a campus tour or to see you again here on another virtual event. We have more coming up every week, so make sure you tune back in. Thank you all so much and have a great night.